Hey everyone, thanks for tuning in. Today we'll be taking a look at the multiple choice section of the 2020 Mathematics Advanced HSC paper. So this section was not too bad. However, there were a few difficult questions towards the end of the multiple choice section. So let's take a look. So question 1 says, which inequality gives the domain of y is equal to root of 2x minus 3? Now we need to recall that whenever we have a square root function, we can't have any negative numbers within this square root, okay? So this, whatever's in there, can't be negative. So in other words, 2x minus 3 has to be greater than or equal to 0, okay? So it just can't be negative. So it can be either positive or equal to 0. And just by solving this equality, we can obtain that 2x is greater than or equal to 3. And then that x is greater than or equal to 3 on 2. So that's going to be our answer. The answer is D. The next question states, the function f of x equals x cubed is transformed to g of x equals x minus 2 all cubed plus 5 by a horizontal translation of 2 units followed by a vertical one of 5 units. Which row of the table shows the direction of the translations? So we need to decide if the horizontal translation was left or right, and if the vertical translation was up or down. Now recall, when we have a function, let's say this function is h of x, okay, and it's in the form of x minus h, in this case cubed, plus k, we have a shift of h units horizontal and k units vertical, and k is going to be up or down depending on whether this is positive or negative. So if k is greater than 0, that's going to be up, and if k is less than 0, that's going to be down, okay? Now, when h, okay, so if I've got a minus h here, that's going to be, so if h is greater than 0, then that means it will be to the right, and if h is less than 0, it'll be to the left, okay? Now we need to obtain our h with this negative. So what we've got here is x minus 2, and so our h is 2 units, and it's a positive 2 units. So that means it's going to be to the right. So now the answer is either B or D, because it's a horizontal translation to the right. And we add 5, so this is going to be our k. And so it's a positive 5, so a positive k, so that means it's going to go up. So to the right by 2 units and up by 5 units, so our answer is going to be B. The next question says that John recently did a class test in each of the 3 subjects. The class scores on each test were normally distributed, and the table shows the subjects and John's scores as well as the mean and standard deviation of the class scores on each test. So these are John's subjects that he does, and these are his scores compared to the mean and the standard deviation of that test. And we need to determine what was his strongest subject and what was his weakest. Now, it's no use in determining which score was the highest and which score was the lowest. It's not about that. It's more about the z-score. So how far is John's score with relation to the mean, okay? So what we need to do is measure each of these subjects' z-scores and use that to determine which one is the strongest and the weakest. Because recall that the z-scores refer to what percentage or what top percentile John's score lies within the rest of the class. So it's no use getting, let's say, 90 out of 100 if the average is going to be 95 out of 100, okay? So with relation to the class, that's a poorer performance than someone who gets 50% and the average is 30%. Now, so that's exactly what we're going to do. We're going to find the z-score. So let's find the z-score for French, okay? So recall that the z-score is equal to the individual score minus the mean all over the standard deviation. Okay, so for French, the z-score is equal to 82, so his score, minus the mean, which is 70, all over 8. Okay, so that obtains a z-score of 1.5. For commerce, okay, our z-score is our score, which is going to be 80. So 80 minus the mean, which is 65, all over 5, because that is the standard deviation in this case. And that would give us a z-score of 3. Okay. And then the final one we're going to do is music. So our z-score is equal to 74 minus 50, all on 12. Okay. And that's going to give us a z-score of 2. So what we can see is that the highest z-score we have is commerce. So that means that's the best that we did. And French is the lowest. Okay. So with relation to the rest of the class, we performed the worst in French. So strongest subject was commerce, weakest was French. So the answer is A. The next question we look at here is what's the integral of e plus e to the 3x? So this should be pretty simple. So just you got to remember that e is a constant. So we can't, when we integrate a constant, it becomes ex. Okay. So the integral of this is going to be ex, because e is just a number, plus 1 on 3 e to the 3x. Okay, and how we obtain this 1 on 3 was it's 1 over the derivative of that function. So e to the 3x, so 3x is like a function we call it, and the integral of that is 1 over the derivative multiplied just by that x exponent. Okay, and obviously this is all plus c, and yeah, so we obtain B as our answer. Next question says, which of the following could represent the graph y is equal to negative x squared plus bx plus 1. Okay, so notice that we have a negative x squared, which is characteristic of a concave down parabola. So knowing this, we can eliminate a and we can eliminate b. Okay, so now it's a matter of whether it's c or d. And what we notice is that c and d have different stationary points. Okay, so one is a positive value of x, so I'm going to call it x1, and one is a negative value of x. I'm going to call that x2. Okay, and we have a certain condition here that b needs to be greater than 0. Okay, and what I'm going to do is find where that stationary point is. So my function is y equals negative x squared plus bx plus 1, and I'm going to differentiate. So y dash is negative 2x plus b. Now I want to find where my stationary point is, so I let y dash be 0. So I say 0 equals negative 2x plus b, and I solve for x to find the x coordinate. So I get 2x is equal to b, and x is equal to b on 2. Okay, so x is equal to b on 2, and we know b is a positive number. That means x is a positive number, so that means the x coordinate of the stationary point is going to be positive rather than negative. So our answer is C. Moving on to the next question, we have which interval gives the range of the function y equals 5 plus 2 cos 3x. So we know that range refers to the y values, and that this is a trig function with an amplitude of 2 and we're a vertical shift of 5. So if we look at what this looks like, where a normal cos graph would look like this. Okay. Now this has a horizontal line, we call it at 0. Okay, and what I'm doing with this extra 5 out the front is I'm moving it up by 5 units. So instead of being 0, it's now going to be at 5. Okay, so it's going to look something. So our midpoint, or like our center line, is going to look something like that, where this is at 5. Okay, So y equals 5. And what I notice is that my amplitude is 2, so I'm going to go up by 2 units above 5 to 7, and down by 2 units from 5 to 3. And my function is going to look something like that. Okay, and it'll keep going. Alright? So hopefully we can see that the range is in between 3 and 7. Okay, and inclusive of these, and as we can see here, that's given by B, from 3 to 7, inclusive of both. Okay. So now we move on to question 7, which says the diagram shows the graph y equals f of x, which is made up of a line segment and semicircle. And now we want to find the value of 0 to 12, so the integral of 0 to 12 of f of x. So recall that whenever we integrate a function, essentially we're finding the area underneath the curve, but we're finding the area with its respective sign, meaning that if I was to try and integrate the area from 10 to 12, so this area under here, okay, I'm just trying to focus it. So this area under here will give us a negative value because it's below the axis, okay? So when I try to integrate this, I'm going to have to subtract this area. So what I'm going to have to do is find the area of all these parts. So I'm going to have to find the area of this rectangle here, okay? So I'm going to call that area 1. I need to find this rectangle here between 4 and 8. I'm going to call that area 2. I'm going to call the semicircle area 3 over here. This triangle here is area 4, and this triangle here is area 5. Cool. So then we got to do our relevant calculations. So area 1 is equal to 4 times 3, which is 12 units. Area 2 is equal to length times height. So its height is 3, and its length is between 4 and 8, so that should be 4. So it's 4 times 3 again, which is 12. Area 3 is now a semicircle. Okay, and recall its diameter is 4 units, meaning its radius will be 2. So recall that the area of a circle is pi r squared. So a semicircle is going to be half pi r squared. So half times pi times r, which is 2 squared. And 2 times 2 gives us 4, divided by 2 is 2. So it's going to be 2 pi. Okay. Area 4 is a triangle of half base times height. So its base is 2, so half times 2 times the height, which is 3, and that gives us 3. And area 5 is half base height, so half times 2 times our height, which I'm going to say is negative 3, because remember, I need to make this a negative area because I'm going to subtract this off them, and that gets me negative 3. And what I do to find the integral is essentially I got to add up all these. So 12 plus 12 plus 2 pi plus 3 plus negative 3, which is minus 3. So 12 plus 12 is 24. Plus 3 is 27. Minus 3 is back to 24. Plus 2 pi is just plus 2 pi. So total area is, or like I should say the integral of the area is 24 plus 2 pi. And as we can see, that is answer A. Okay, cool with that. So the next question we look at is one of the harder ones, I'd say, and it's saying which of the following inequalities is correct. Now, that we need to notice a few things. So it's talking about the second derivative, the first derivative, and just like the normal function, and what those respective values are in relation to each other and in relation to 0. So first thing we should do is consider if it's positive or negative. What we can determine is that f of 1, okay, which is just the y value at x equals 1, is positive. So that's greater than 0. We can say the derivative at 1, okay, so remember the derivative at 1 describes the gradient at 1, the gradient of the tangent. So if I'm to construct the tangent line to this point, I'll obtain something like that. And hopefully you can observe that its gradient is positive, okay? So it's greater than 0. Then I'm going to determine the concavity at 1. Okay, and I'm looking at this whole thing here, and what I can see is if I was to continue it, it looks like it wants to kind of turn back. Okay, so what I say is that it's concave down, which indicates a negative concavity, so it's less than 0. So what can I gather from this? I can gather that the answer is going to be either A or B, because we see that in A and B, the second derivative, so the concavity at x equals 1 is less than 0 in both of these cases, whereas in C and D, we're saying it's greater than 0, which is incorrect. So we've ruled off C and we've ruled off D. Now it's a matter of, well, what's the difference between A and B, and then which one is it? So what we notice is that in A and B, they're saying the derivative and its y value are both greater than 0, okay? But the question is, which one is bigger? Is the y value bigger than the derivative, or is the derivative bigger than the y value? And how we can kind of see this is, well, we can say that the derivative at x equals 1 is going to be the gradient of this line. And we notice that the gradient of this line is given by rise over run. So we can say the rise. So what's this y value? And this y value here is f of 1. So the rise, so I'm going to say the gradient is rise over run. And our rise is equal to y1 minus y2. So where am I going to rise from? And I'm going to pick a nice easy point and say this intercept here. So I'm going to say it's f of 1 minus b, where b is just the intercept. Sorry, that's my rise. And then my run is from 0 to 1. Okay, hopefully you can see that. So it's going to be on 1 minus 0, which is just 1. And I obtain that my gradient is f of 1 minus b. So if my gradient is f dash of 1, hopefully you can rearrange this formula and obtain that f of 1 is equal to f dash of 1 plus b. So what we're saying here is that f of 1 is this gradient plus something else, which would intuitively indicate that f of 1 is larger than f dash of 1, because in order to obtain this number from here, we need to add something to it. Okay, so it's saying this is a small number, and when we add something to it, it makes this larger number. So that means f of 1 is greater than f dash of 1, and our answer is A. Okay. The second last question says, suppose the weight of melons is normally distributed with a mean of mu and a standard deviation sigma. A melon has a weight below the lower quartile of the distribution, but not in the bottom 10%. Which of the following most accurately represents which weight the melon lies? So this is the main piece of information here, okay? Because we need to consider what area it's going to be, okay? So it's saying it's saying we're below the lower quartile. So the lower quartile, remember, is at 25%. So we're less than 25%, okay? But not in the bottom 10%. So we're greater than 10%, okay? So we can say our z-score is that, okay? So we need to be below 25% and greater than 10%. Cool? So the question is, which of these areas is, is characteristic of this region? And we need to remember the 68, 95, and 99 rule. So, 98 rule. So when we're one standard deviation away from the mean, okay, I'm going to do it up here. When we have something like this, and we have one standard deviation away from the mean, so mu plus sigma, and this is mu minus sigma. The area between here to here, okay, so from here to here is 68% of the data, and if we go, down 2 standard deviations, so mu minus 2 sigma, and then let's say mu plus 2 sigma, okay, so the percentage of data from here to here that's going to be 95%. Okay? So using this knowledge, half of this is going to be 34. So this is 34%, this is 34%. And that means from here to here, the area between there is going to be half of 95, which is 47.5%. And 34 of that percent is taken up. So 47.5 minus 34 gets us 13.5. So this here is 13.5% of data, same as this. Okay? Alright, so, and then that leaves this remaining. So because this is all 5%, this is so that means what's left over is 5%. So this is half of it, and this is the other half. So that's 2.5%, and that's the other 2.5%. So what we can see is that we need to be above 10 and below 25%. Okay? So up to this point, that's 2.5% of the data. If I go a step further, okay, that's an extra 13.5%. Okay, so if I add these two things together, I'm going to get 16% of my data. So up to this line, up to the first thing here, that's 16% of the data. And recall, I need to be within that, so I need to be above 10%, which would indicate that I'm probably going to lie between a region around here, okay? Because if this is 16%, I need it to be a little bit below, so like my minimum can be a little bit below 16%, and my maximum can be a little bit above 16%, and that hints towards C being the answer, so this curve down here. So as we can see, this is probably indicative of 10%, and this is 25, with the middle here being 16. Okay? Alright. Now the final question of the paper was quite a tough question. So if you got this question, good job, because it is quite difficult. It's saying the graphs of two functions y equals f of x and y equals g of x are shown. Okay, so this is the graphs and what it looks like. Alright. And then the question says, define h of x equals f composed with g of x. So we're defining a new function h of x as f of g of x. And we're saying how many stationary points does h of x have? Okay? Is it 0, 1, 2, or 3? So what we're going to do here is we need to consider kind of whether, or sorry, we're going to kind of consider how the function works. And what we're going to say is, recall the basic definition of a function. If we have a function, okay, f of x, what I put into here is my x values, okay? So that's the x values. And what comes out, which is kind of like from my f, I can say, is going to be my y values. And it's these values which determine like what it looks like. Okay? So we have to kind of rely on these y values because that's what determines where along the y-axis these respective x ones will lie. So whatever comes out, okay, whatever's going to come out depends on the x, okay, but it's going to resemble something which looks like the f. So this is kind of like important to recall because when we get this definition of f of g of x, so when we consider now f composed with g of x, this g of x here now becomes our x values, okay, of the f. And the f is going to be the y values and essentially what it looks like. Now the trick here is that, well, what the hell is like g of x? So these x values that I input to my f function are going to be the y values of the g function. So how this process works is I input an x into g of x and I come out with a certain y value for g of x. This y value I then put in, okay, into f of x, and what I get out is something, a y value which is from the f function. This means that whatever values I put in to this h of x function, it's going to look or take shape of f of x, okay? So it's going to have the y values of f of x. And recall that we want how many stationary points h of x has. So essentially it's saying how many of them lie here. So how many values get me a y value of 2 basically. And what we notice is that this is when there's an x value a little bit less than 1. Okay? And recall, what are these x values that we're putting into the function f of x? And it's going to be g of x. And what's g of x? G of x is the y values. Okay? Because we're saying y equals g of x. So we're putting in the y values. Which means I need a y value of g of x a little bit less than 1, because any one that any of those values which I sub into my f function will result in this stationary point. So what I do is I look on my graph and I line up a y value of a little bit less than 1. Okay? And I do, a little bit of a dotted line, and I can see that this occurs in 2 points on the g of x line, one here and one here. So at x equals, let's say, 1.7, and at x is 4.3, let's say, when I sub them in, okay, when I sub them into h of x, I'm going to output this stationary point, which indicates that there's 2 stationary points because there are 2 values of x for which this happens. Okay? This is a very, very difficult question, and it really requires proper understanding of the concepts involved. Okay? That does it for the multiple choice section of the HSC. I hope you learned something. Take a look at my other videos where I will take you through section 1 and section 2 of the paper. Okay? Best of luck with your studies, and I'll see you next time.